Hello dear students, I welcome all the standard 7 students on this online classes. So last class already we have discussed about a simple pendulum, different parts of the simple pendulum like extreme positions, mean positions, bob, rigid support, string and oscillations, amplitude of oscillation, time period, frequency, length of a pendulum. These all things already we have discussed which are related to simple pendulum, and I hope all of you have understood that one properly. Okay. Today we will be going to discuss about one experiment which is given in your book, and that experiment is about how to measure the time period of a simple pendulum. You know time period means what? Time taken to complete one oscillations. Okay. So how to measure that time period of a simple pendulum, that one we will understand. Okay. And one more thing also we will discuss, that is the factors which are affecting the time period of a simple pendulum. What are the factors which can affect or not affect the time period of a simple pendulum? Okay. So without delaying, let's get started that one. So before going to start or discuss about that experiment, let us revise one more time about the different parts of the simple pendulum. Okay. Here in figure 2.13 you can see one metal bob is there which is rest at its mean positions, and one string is there, and by the help of that string that metal bob is hanging, and another end of the string is attached with the rigid support. Okay. So when that bob is not moving anywhere, if it is in the state of constant, at that time the positions of the bob is called as its mean positions, and while it is oscillating, and two extreme points we will get from where that bob will again come back to the mean positions. Okay. So here A and B are the two extreme positions, O is the mean positions. Okay. And which one is bob is also indicated here, then string is also given, then rigid support is also given. Okay. I hope all of you have understood that one. So let's start to discuss about the experiment, okay, which is the experiment 1 is given in your book. So how to measure the time period of a simple pendulum? So first, what are the apparatus required to construct that simple pendulum? That one is given. Take a point mass, that is heavy metal bob. That means heavy metal bob means solid sphere, okay, and made up of that metal with hook. Then the next one, an inextensible string, that string cannot be expanded, inextensible string, then a rigid support and stopwatch. Okay, these all are the apparatus required by the help of which we can perform that experiment. Okay. Then the next step, what we have to do, tie a piece of string to the bob. Obviously we have to tie that piece of string to the bob and attach it with the rigid support. That means suspend the bob from the rigid support. Okay. Then what we have to do, already we have constructed that simple pendulum. Now the experiment time. Displace the bob slightly from its mean positions. Then what we have to do, we have to move that simple pendulum from its mean positions, or we can say that one, displace the bob slightly from its mean position so that it start oscillating with a small amplitude. So whenever we are trying to move that simple pendulum or displace that simple pendulum, it start oscillating only. The motion of the simple pendulum is called as oscillatory motions only. So it start oscillating with a small amplitude. Amplitude means, you know that one, maximum displacement from its mean positions. That means the distance or the displacement between its mean positions and extreme positions. That one is called as the displacement. Okay. Or that one is also called as here amplitude. Okay. So start a stopwatch and note down the time of 20 oscillation. So while it is oscillating, at that time we have to start the stopwatch and we have to note down how much time it is taking to complete 20 oscillations. So we have to calculate or count for 20 complete oscillations, okay, and we have to measure how much time it is taking. So let us take T be the time taken to complete 20 oscillations. Okay, let us see whatever the time period it will come, let us take here as t is the time taken to complete 20 oscillation. Again push the bob to one end and measure the time for 20 oscillations. Okay, we have to repeat this experiment. Then what we have to do, divide the total time by number of oscillations to get the time period. Okay, in both the cases. Okay, so the time period, how to calculate? The time taken to complete 20 oscillations, that is t divided by 20. If we will do that one, then we will get the time period. And time period means you know that one, time taken to complete one oscillations. Okay, so in that way we can calculate or we can measure the time period of a simple pendulum, or we have to repeat this experiment for 3 to 4 times, and what are the results if it is, are coming, we have to find out the average of the result, and finally we will get the time period of oscillations also. Okay, so I hope all of you have understood this one, how to calculate the time period of a simple pendulum. Okay, so when the school will be reopened, at that time I will show you also. Okay, then the next one, the factors affecting the time period of a simple pendulum. So what are the factors which can affect or does not affect the time period of a simple pendulum? That means on which factor it is depend, or which factor can cause in the change in the time period of a simple pendulum. So let us know about that one. First one, nature of the material of the bob. So is it that means the time period is depend upon the nature of the material of the bob, or it does not depend upon the nature of the material of the bob? So let us know about that one. So here it is written that the time period of oscillation does not depend on the material of the bob. So time period will not change if the material, what is the nature of the material, okay, whether it is made up of iron or steel or something else, it does not depend upon the material of the bob. Okay, time period will not change. If the material of the bob is changed, still it will not change. Okay, so the next one, period of oscillations, that is amplitude of oscillation. So time period is not depend upon the amplitude of the oscillations also. Amplitude of oscillations means I said that one. Yes. So maximum displacement from its mean positions, that one is called as the amplitude of oscillation. So time period also does not depend upon the amplitude of oscillations, whether it is oscillating with a small amplitude or oscillating with a greater amplitude. The time period will remain same only. Okay. Then the next one, third factor, length. The time period of oscillation in a simple pendulum is directly proportional to the square root of its effective length. So here is a relationship between that time period and length of the pendulum. So time period is directly proportional to the square root of its effective length, or if we will square both the sides, what we will get, t square is directly proportional to the length. Then what is the meaning, what we can understand from these relations? If the length is decrease, then the time period will also decrease. Okay, and if the length is increase, then the time period will also increase. Okay, and if we are doing or performing that experiment repeatedly, and if we will try to find out the ratio between that t square, that is time period square, divided by length of the pendulum, and if we are continuously changing the length of the pendulum and measuring the time period, and after that if we will find out t square divided by L, it is always coming constant. Okay, so length is directly proportional to the, or time square or time period square is directly proportional to the square root of length. Okay, then the next one, mass of the bob. The time period of oscillation does not depend on the material of the bob provided. Which material it is provided? Okay, and see, previously we have learned about the nature of the material. Whatever the nature is there present in the material, it does not depend upon the nature of the material. Then the next one, period of oscillations. It does not depend upon the period of oscillations also. That means it does not depend upon the amplitude of oscillation. Then mass of the bob also, it does not depend. That means the time period will not change according to the mass of the bob also. Okay, so that's why the time period of oscillation does not depend on the material of the bob provided. Okay, but one thing can affect the time period, or one thing can change the time period of simple pendulum, that is the length of the simple pendulum. Okay, so I hope all of you have understood this much. Thank you.